This is week 11. Starting out lines is 1 through 5. So why finance? This downloads historical market data. Pandas is used for the data manipulation and the data frame support. NumPy is going to do it's used for the numerical operations. And matplot is used for plotting graphs. And the Skippy, this is for running the numerical optimization that will come at the later end. So line 10. Here we define our tickers of Walmart, Amazon, Apple, and Tesla. Line 12. Um, this is the data download. So data download will download the monthly data from April 1st of 2022 to April 1st of 2025. Line 13. Here we get the closing price. So the closing price so the drop now right here is used. This is used to ensure that like any row with missing values in there in the closing price is removed. Line 18. So here we calculate the returns, the percent change. This will compute the percent change in the closing prices, and the drop now removes the first row from with uh, no values. So here we're gonna our mean of the monthly return and the monthly risk. Line 27, we're calculating the annual return, then annual risk, and then the covariance matrix. Line 31, so this is creating a data frame that contains the points, so the mean monthly return, the monthly risk, the annual return, the annual risk. It would print out the results here. 43, line 43. So here we are just setting up a frontiers simulation of like a number of portfolios that defines the number of random portfolios to generate. And so we're going to be generating 5,000. Line 47, so the NP random here, so this generates a random weight for each asset. Move down with line 50. Here we're computing the portfolio return, the risk, and the Sharpe ratio. And then lines 54 through 57, we're printing out the results we get from it. And line 59, here we're creating another data frame of our portfolios. So this PD data frame. And line 64, so here we're defining our portfolio matrix or metrics, portfolio return and portfolio risk. And then line 69, the purpose of this is it's used as the objective uh, for optimization. Find the negative Sharpe ratio. Line 74 and 76, or through 76, this is the optimization setup that we're using. So line 74 is our constraints. 75 is our bonds, which just defines the lower and upper limit for each weight, which is 0 and 1. And X is our initial weight. Lines 80. So this method SLSQP. So what this is doing is we're using the sequential least squares programming algorithm to solve the constraint optimization problem in our kind of metrics, I guess, or our display. Lines 82. So the optimal weight. So this optimize.x. So the purpose of this is that it contains the optimal weight that's found. Lines 8 99 through 95. So here this would display our results in our terminal of the portfolio return, the risk, and the Sharpe ratio. And then lines 100 to 102. So here this is the purpose of this, is that we create a scatter plot. We're creating the scatter plot of all the simulated portfolios, 103 to 104. So this highlights the optimal portfolio that we get in our extra figure. And then here 105 to 110, this is just the extra, the labels, the titles, legends, the grid. So the plot is to plot it out. 118, here we're downloading our benchmark data of monthly data from the S&P 500, which is the GSPC. And then 120, person is dropping now. So this will extract the closing price and clean them. And then 123. So here at the end is cumprod. This will compute the cumulative product over time, simulating the growth of the initial $1 investment that we have starting out. And then 130 to 132. So this is combining our portfolio value and the benchmark series. That's putting it all into a data frame. And then lines 135 to 139 or 140. This will just plot out our chart and the growth of the $1 compared to our S&P 500 portfolio, or our optimized portfolio versus S&P 500 with their $1 investment. So here we get to see the risk and return summary of the monthly return, the monthly risk, the annual return, the annual risk of Apple, Amazon, Tesla, and Walmart. And then going down to our optimal portfolio weights, weight of this for Walmart, that's Amazon's, Apple's, Tesla's. And then our portfolio return, the volatility, and the Sharpe ratio of that portfolio. Okay, so on this graph, we get to see our efficient frontier with the optimal portfolio, with the expected return obviously high, with the risk and volatility being on the lower end. And then we get to see the graph for our performance comparison of our $1 of our growth of our $1 from our optimized portfolio versus just following the S&P 500. And that is it.